Today we're starting our unit on statistics, and the first section here is on random sampling. Statistics is the area of math that deals with collecting, analyzing, and interpreting data. All right, so that's what we're going to do. Parts of statistics will feel very different than some of the regular math we have done, but it's a very interesting and ever-growing section. Most jobs these days, or I shouldn't say most, but well, maybe deal with data and analyzing data. All right. Characteristic of a population is called a parameter. Um, so sometimes we don't use the whole population, and so that's why we use statistics. All right. To draw accurate conclusions, we have to remain unbiased. That's very important. Bias is an error that results in a misrepresentation of a population. All right, so one of the things we're going to focus on here to avoid bias is that we have to remain random. We'll also look at some other areas of bias as well. I'll link this video on our online platform. All right, it's a good video that teaches the different types of random sampling. Though they talk about cluster sampling in the video. All right. Simple random is the first type, just as a way you set up that each member has an equal chance of being selected. All right. Think of if everybody has one card in that classroom when I'm drawing cards, then that's kind of simple random. All right. Systematic. If I go around the room picking every third person, that would be systematic. That's a set interval. Self-selected are volunteers. All right. Convenience are you select only the people that are readily available. And stratified, members are selected from similar non-overlapping groups. It's kind of hard to explain via video here, so it would be like we found some way to sort ninth graders at Port Huron High and Northern, and then we pick from those groups. So they're sorted the same way, and then we're picking from, so the groups are similar, but yet they're different because they're different schools, and we draw from both groups. Okay. And I have all the answers in. So first, let me clear them out. All right. So example 1 here. I don't know if I did that. Says the administration at Jefferson High School developed a free app to help students with studying and organizing. At the end of the school year, the students were asked to complete an online survey about their satisfaction with the app. Classify the sample. So when you go to classify the sample, you got to first think, who is the population? What was the population? In this case, it was the entire student body. All right. All right. So all students could have been selected. Right. What was the sample size? The sample was just those who volunteered, those who responded to the survey. And so therefore, the sample, you can classify this. This would be a case where it is a self-selected. Only the people who chose to respond to the survey were part of the sample. All right. You think this through now. Take a second. Well, let's read it together here. The class president wants to play a song to celebrate the senior class at the beginning of their graduation ceremony. She assigns a number to each of the 754 students. Then she uses a random number generator to select a sample of 80 seniors and ask them for their top 5 songs. Classify the sample. take some time here, pause the video, and think this through. All right, you may continue to hit pause if you haven't come up with your answer. All right, the population, that was all seniors. Identify the sample, those were the 80 selected. All right, and it was said a random number generator, so everybody had equal chance, and so it was a simple random classification. Now we're going to talk about bias. All right, the Traffic Commission took a random sample of travelers using Route 15 and determined the average daily commute during rush hour. As reviewing the results, the commission proposed expanding the road from 2 lanes to 4 lanes, identify bias and potential interest in the sample. Now, just reading that, you can probably think of ways that this could be biased statistics. But let's look over here at what the statistics they came up with are and not just go on the story itself. And the first thing that pops to me is this number right there. All right. Now, I want to give them the benefit of the doubt, and I'm going to say that sample size isn't 10 people, but 10% of the people. And even that is pretty small sample size. All right. And so I want to say that one of the potential bias of the bias here is very small sample size. All right. Especially, I mean, it could be just 10 people. That's not a lot of cars if it's taking 26 minutes to go 10 miles during rush hour. Right. You could also think other biases here. There's usually 2 rush hours. There's usually a morning and an evening or afternoon rush hour, and maybe they only do one. Right. Potential interests. Right. Potential interests are from such a small sample size. Maybe we just happen to get 10 people that were all going to their job, and their job is working for a contractor who fixes roads. Well, then, yeah, they're going to be all about fixing the road and expanding the road and getting their boss and themselves more money. So there's all kinds of ways this could go wrong and interests that could be involved. Example 3, another bias example here. Restaurant owner wants to determine which kind of meals she would add to her menu, vegetarian options or more traditional meat dishes. One of the things I fail to say is you always want to think when you're evaluating bias, what is the purpose of their survey or what they're doing, their study, right? And here the purpose is to not only like pick a dish, but we want popularity, right? We want something that people are going to buy. Right? I don't necessarily want something that I like. I want something that people are going to give me money for. Right? And so she releases a survey to her customers asking the following question. Do you prefer a plain salad or delicious steak? Identify any bias in the question. And I bet some of you are thinking right now about the bias and the way she's going to ask people. All right? Because if she wants to attract new customers, she probably could come up with a better way. But I want to go and look at the question here. I think the descriptors there are biased. All right. It might be the way I would say it because I'm not a big salad fan. All right. But the way it's described is to me a huge bias because your descriptions. All right. So I would say the adjectives they use, the descriptors limited the survey. All right. Think about this way I said. Is it a plain salad you want, or do you want a delicious steak? All right. And so the way it's worded there would be a bias. All right. Last thing we're going to get into and look at an example of today is the way you study the complete the study or the way you draw your statistics. You could use a survey. All right. So you guys all know what a survey is. You got to make sure when you're doing a survey for statistical purposes that you have a clearly stated objective. You know what the population you're going to attack or analyze is, and that your questions themselves are unbiased. In an experiment, you need two groups. All right, so you have one group that you're going to undergo some change. You're going to have them do something different than their normal routine in some way. And then you're going to have another group that's a control group that isn't going to do that different thing. If you're in science class, maybe they're receiving the placebo pill, but it doesn't have to be a pill. It can, anyway, they're not changing their routine. So you have two different groups that you can compare. That's an experiment. In an observational study, everybody gets to experience the change or the thing or see what's happening, and you just are watching how they react to that change or what's happening. Bias is something, again, we need to avoid. All right. And we need to focus here on making sure that we have random selection. All right. To accurately represent the population. So we got to have a proper size, and the way they're chosen needs to be random. We also need to avoid questions that are confusing. They encourage members of the samples to maintain a certain way, maintain a strong reaction, and address more than one issue at a time. Go back to like the plain salad versus delicious steak. I mean, that's not really confusing, but the descriptors are wrong. But also, like, I'm looking for a popular dish, and it could be anything. And so anytime it's a this or that question, it's probably biased. All right. Very few situations are truly this or that. There's usually other alternatives. Last example, a research team wants to test new football uniforms, and they want to appeal them to young adults. They randomly select 100 young adults to view the different uniforms. The research team observes and records the reactions. All right. And so, what is the purpose of the study? And they want to see which unis are popular. All right. I'm going to call them unis for uniforms. Popular. Okay. Does this situation represent a survey, experiment, or observational study? All right. Well, all 100 people are just going to get to see the jerseys and react, and they're just noting their reactions. And so this is an observational study. And the sample here, the sample size, the sample group is the 100, and the population was just all young adults. If you are a geezer like me, then you couldn't have been chosen. All right. And that is section 1. Thank you for watching and listening, and good luck.